Okay, so example 6, you guys. What we're going to do, we are given f of x. Again, we're using function notation right now, which function notation has the nifty f of x in it. Okay, and what we're going to do, we're going to state the transformation in the problem, and then we're going to find g of x, which will be the f of x function transformed into the new function. So we'll be finding both of those. Okay, so in this problem, again, this is f of x, x to the third plus 2x squared minus 4x plus 8. Okay, and we will be stating the transformation and solving for this bad boy down here. So let's get going. All right, so it says g of x equals 1/2 times f of x. So first of all, let's figure out what the transformation is. So the 1/2, you guys, is in front of the f. Now, the only thing in front of the f is the a, and the a value multiplies to the f. Okay, so this is an a value. Alright, and remember, a values deal with everything vertical. So remember, 1/2 makes the graph get wider, and the way that we make something get wider vertically is by vertically compressing. If we smush something down vertically, we'll smush it and make it get wider since we are smushing it down. Okay, so this will be a vertical compression by a factor of 1/2. So vertical compression by a factor of 1/2. All right, so typically in the last problems that we were working on, we would be done in this step. But not only does it say to state the transformation, it also says to find g of x. So I want to know the equation that will force f of x to vertically compress. So let's solve for this bad boy right now. All right, so g of x, let's see, I'm going to pick a nifty color. G of x will equal, all right, as in all these problems, okay, what's going to happen? I'm going to put a parenthesis down every single time, and what goes in our parenthesis is f of x, okay, or what is in the parenthesis will go in here. So f of x will be inserted into the parenthesis, okay, so if f of x is going in here, and this is 1/2 times f of x. We need to think about where is this 1/2 going. Is it going in the parenthesis, in front of the parenthesis, or behind the parenthesis? So let's think about it. This right here is f of x. This is 1/2 times f of x. So let's think about where will the 1/2 go? Holy hot dog, you guys are so smart. Since 1/2 is in front of f of x, the only spot in front of f of x is right here. So my 1/2 is going to go right here, and f of x is going to go right here, with which f of x equals all that right there. So I'm going to put all of that in my parenthesis. So we have x to the third plus 2x squared minus 4x plus 8. And now all we have to do, you guys, is solve this thing, which, when we have a number outside of our parenthesis, all we do is distribute that bad boy, and bam, we'll be done with g of x. So let's see what happens. Okay, so I'm going to be distributing 1/2 to each term. So g of x will equal 1/2 times x to the third. Well, 1/2 has nothing to combine to. There's secretly a 1 in the front, so 1/2 times 1 will give me 1/2. And then we're just left with x to the third. Okay, 1/2 times 2x squared. So 1/2 times 2, or half of 2, is 1. Okay, as whenever you have a 1/2 or a fraction that's 1 over something, you simply just divide by the number in the denominator. So 2 divided by 2 will give me 1, or half of 2 is 1. So this will be 1x squared, which is also the same thing as x squared. Alright, then 1/2 times negative 4x, or half of negative 4 is a negative 2x. Or again, you could say negative 4 divided by 2 is negative 2. And then finally, 1/2 times 8, or 8 divided by 2, is 4. And that's it, you guys. We have found g of x. Insane, right? And that would be it for the problem. So we stated the transformation, and then we found the equation that would make f of x vertically compressed. So if you graphed this function into your calculator, and then you graph this one, this graph should be a little bit skinnier by a factor of 1/2. So it should stretch out, or I'm sorry, it should be a little bit skinnier I'm sorry, a little wider. Sorry, guys. 1/2 will vertically compress, which will make it wider. So it'll be vertically shorter by a factor of 1/2, which will make it wider. Pretty cool, right? Alright, so example 7. Same kind of problem, a little different because the number we're dealing with is in a slightly different spot. If you think you got it though, you can pause the video and fast forward to the end of example problem 7 to see if you got it right. Alright, so the first step, it says to state the transformation. Alright, so I have this plus 7 right here. It is added to the end of f of x. So we look at our nifty transformation notation. The only thing added, remember this is outside of a parenthesis, so the only thing added outside of a parenthesis is the k value. The only things that are outside of the parentheses, you guys, are the a and the k. So this is the k value, and remember k, you think kangaroo goes up and down, and you don't think the opposite with the k. You do what you think it would do. So this is a k value. And let's see here, when the k value is 7, if we're going up and down and we don't think the opposite, holy hot dog, you guys are so smart. This is going to go up by 7 spaces, so up 7 spaces. Or you could also say vertically translates up 7 spaces, whatever you want to say. I'll take up 7 spaces though. Alright guys, so now we want to come up with the equation that will make this graph move up 7 spaces. So again, whenever I start these, I'm going to have g of x equals, okay, I'm going to have a parenthesis, which remember our parenthesis is always where f of x goes. So I have my parentheses, which f of x goes in here. Okay, and I have to figure out where this plus 7 will go. So plus 7 is outside of the parenthesis. It's after the f of x. So if this is f of x, where will the plus 7 go if it's after the f of x? Holy hot dog, you guys are so smart. It won't go in the front because this is not before f of x. It won't go in the parenthesis because it's not inside of my parenthesis for f of x. So it will have to go on the end of the parenthesis in the same spot that it's currently located in. So this will be plus 7 on the end. Alright, so all we're going to do, we're going to put f of x in here, then add 7 to it, and then we'll be done. Pretty cool, right? So f of x is all that right there, so I'm going to insert that into my parenthesis. So we have x to the third plus 2x squared minus 4x plus 8. Alright guys, so I have f of x plus that. Now remember you guys, think back to when we were adding polynomials. Think about what we do when we have a parenthesis added to something. Well, addition, the order of addition, you guys, does not matter. Okay, so what we're going to do when you have a parenthesis added to something, you're going to drop the parenthesis and then combine those like terms. Okay, so I'm going to drop my parenthesis. So I have x to the third plus 2x squared minus 4x plus 8. And then my plus 7 on the end. So I'll just drop that down. Alright, and after this, we just combine like terms, which the only like terms I see are these two on the end. There are no other like terms. So 8 plus 7 will give me 15. So my final answer will be g of x equals x to the third plus 2x squared minus 4x and then plus 15. And bam, we are donezo. Guys, so again, this is the equation that will be 7 spaces higher than this equation. So if you want to, either on your calculator or on Desmos, I like Desmos because it's a pretty graph and it makes it really big for you. You can type in this equation. This is like your parent function, you guys. This is your start graph. Okay, and your end graph will be this one. And when we did it correctly, this will be f of x shifted up 7 spaces. Holy hot dog, right? I know. Alright, guys, we have one more, which if you notice, you guys, example 8 looks very similar to example 6. So if you think you got example 6, I highly encourage that you try example 8 on your own. Pause the video, fast forward to the end, and see if you get the correct answer. Alright, guys, let's get going. So, we have g of x equals -1 times f of x. So, the -1 is in front of the f. The only thing in function notation in front of our f is that bad boy right there, the A. So this is an A value. And remember, you guys, whenever something's negative, if it's an A or a B value, it will reflect over something. And since A values do everything vertical, let's think about this. Okay, the only axis we'll be reflecting over if we're reflecting in a vertical motion, okay, will be the x-axis. We'll cross the x-axis. So this is an A value, and it'll be a reflection over the x-axis. So it will reflect over the x-axis. Nice, nice. So again, A values, it goes in a vertical motion. It reflects vertically, it stretches vertically, and it compresses vertically. So just keep that in mind. Alright guys, last up, we just got to solve for g of x, and we're done. So remember, I like to start with g of x and a parenthesis, which remember, inside of the parenthesis, f of x is always inserted into the parenthesis. So this will be f of x, goes right in there. Alright, we have to think about where will this negative one go? Will it go in front of the parenthesis, inside of the parenthesis, or on the end of the parenthesis? It's negative 1 times f of x. So if this is f of x, where will negative 1 go? You guys are too cool for school. It does go in front of the parenthesis. You guys are so smart. Okay, so negative 1 will go in front of the parenthesis, and I'm going to put f of x, which is all the way up here, into my parenthesis, which, if you notice, you can see f of x right here. So I'm going to have this right here so you guys can see it. Okay, so f of x is all this right here. All that nifty stuff. So I have x to the third plus 2x squared minus 4x plus 8. Alright guys, and all we gotta do now is solve for g of x, and then we'll be done. Alright guys, which if I have a number in front of a parenthesis, the way that we solve is by distributing that bad boy to all the numbers. Then we'll be done. Okay, so negative 1 times x to the third will give me negative 1 x to the third, or you can just write negative x to the third. Negative 1 times 2x squared, negative 1 times 2 is a negative 2. So this will be negative 2x squared. Alright, negative 1 times negative 4x, a negative 1 times negative 4 is positive 4, and we're left with the x. And then negative 1 times 8 will be negative 8. Alright, and typically, you guys, you try to combine like terms after this, but if you see, there aren't any terms that contain not only the same variable, but the same exponent. So, we are donezo. Awesome, right? Alright, guys, and again, this is the equation that will force this function right here to reflect over the x-axis. So, if you were to graph this into Desmos or your calculator and then graph this graph would be the original graph flipped upside down, which is pretty cool. Alright guys, I hope you have fun dealing with the A and the K value with reflections. In the next example videos, I'm going to show you how to do the same thing, but with the B and H value, which those work a little differently. So watch yourself. And that's it.